This program shows you on how to perform an ANOVA. It reads data, it generates a box plot, it does a one-way ANOVA, a two-way ANOVA, and also it does post hoc tests. So let's first read the data. By typing fix and the object name we can see the data. So we have sample ID, mouse ID, genotype, whether we have tumor, wild type or knockout, type of treatment, and the size of tumors before treatment and after treatment. Now let's do a one-way ANOVA. Let's ask the question, is at least one treatment different in the wild type tumor? First, you have to select, of course, only wild type tumor. You can do this by simply pulling out only the rows for which the genotype is equal to wild type. Let's generate this object. Then we can do a box plot where we separate the tumor sizes by different treatments. You can look at this. Let's look at the box plot. Remember, here the line shows you the median, here is the 25th, and here the 75th percentile. So it's you, and this one here is 0, and here's 100th percentiles. You have for placebo, for treatment A, and for treatment B. It looks like placebo is much larger than the other two. Let's close it. Now let's perform an ANOVA. So what we do is a one-way ANOVA. We actually have a model where we want to look at the tumor size and see how this is influenced by treatment, right? So our model looks like this. The function is AOV, and then we have the tumor size as a function of the type of treatment. Let's do that. And we can type summary to actually see the results of the ANOVA. So what we can see here, that at least one group, assuming a confidence level of 0.05, is significantly different from the others. If we do a post hoc test, Turkey AHSD, you can see here the different pairwise comparisons, and you actually can see that treatment A is significantly different from placebo, and depending on the confidence level, of course, also B versus placebo. Now let's go to the next step. Let's do, using the same data, a two-way ANOVA, where we actually ask the questions how the effect of the treatment and the genetic background affects the size of the tumors. So we also can include an interaction term, whether there is an interaction between genetic background and treatment. So for that, it would be the tumor size is a function of the treatment, of the genotype, and the interaction term. For that, we again say the tumor size after treatment as a function of the treatment, genotype, and the interaction term. Let's generate this object. Let's look by typing summary of the object, and we can see here indeed there is a significant difference between the in the tumor size of independence of the treatment, genotype, and also assuming a significance level of 0.05, also it's the two factors are dependent. Then we can of course do again a pairwise comparison.